So I want you to picture a bicycle for a second. Just a standard, reliable 10-speed bicycle. Use it to commute. It gets you from point A to point B, and you know exactly how the gears work.
Right, just a normal bike.
Yeah, exactly.
Yeah.
Now imagine strapping a literal Saturn V rocket engine to the back of it,
Yeah.
lighting the fuse, and just, hoping the handbrakes still function.
I mean, you are looking at a recipe for rapid, spectacular disassembly there.
Oh, absolutely.
The frame of a bicycle just isn't built to handle that kind of propulsion. It would vibrate apart before it even left the driveway.
Yeah, and that friction, that terrifying vibration between a vehicle built for one speed suddenly forced to travel at another is exactly what we're exploring today. So welcome to the deep dive.
Glad to be here.
Our mission today is to really unpack this central, frankly startling theme running through our source material. We're looking at the sheer breakneck acceleration of artificial intelligence and what actually happens when this concept of speed without wisdom collides with the physical world you live in.
And our foundation for this comes from issue 57 of the Shift Register, which is dated June 5th, 2026.
Right.
To give you a sense of the tone here, ChatGPT actually summarized this specific newsletter as a weekly wake-up call for IT leaders sleepwalking into AI disruption.
That's a strong summary.
Yeah, it really is. It is dense, it is urgent, and it covers ground from, basic software development all the way up to global cybersecurity.
And whether you are prepping for a high-level tech meeting today, or you're just trying to wrap your head around the dizzying pace of the modern world, this deep dive is going to arm you with the specific insights you need.
Because the bicycle is human society, right?
Yes, exactly. The bicycle is us, the rocket is AI, and we are already in motion. We really need to start by looking at just how fast that rocket is firing right now. Specifically, I want to focus on Andrej Karpathy's new open source project, which is called Auto Research.
Yeah, Karpathy is a massive figure in this space. I mean, former Tesla AI lead, co-founder at OpenAI.
Right.
When he drops a project, the entire tech world stops and pays attention.
They really do.
But what makes auto research so disruptive isn't that it's some massive, closed-door corporate monolith. It's actually the exact opposite.
It's just a simple 630-line script on GitHub.
Yeah.
That's it. But the specific detail the author of the newsletter highlights here is it's mind-blowing. This script managed to automate the scientific method overnight using AI agents.
And just for anyone unfamiliar, an agentic system isn't just a chatbot that, answers a simple question.
Right, it's not just typing into a box.
Exactly. It's an AI that can break down a goal, form a plan, execute code, look at the results of that code, and then try again entirely on its own.
And the author notes that by setting these agents loose, this single script compressed 8 years of machine learning optimization research into just 17 hours.
Wow.
Yeah, 8 years of human effort, done while we were basically asleep.
We really need to pause and think about the mechanism there, because traditionally scientific research is gated by human working hours.
Right, you need sleep.
Yeah, you form a hypothesis, you run a test, you look at the data, you sleep, you eat, you write a paper. This script fundamentally changes the bottleneck of innovation itself.
So progress is no longer tethered to how fast a researcher can read or type.
Exactly. The AI forms the hypothesis, writes the code to test it, analyzes the failure, and iterates 1,000 times a minute. It's now limited literally only by how much raw computing power you are willing to burn.
That level of acceleration feels like it should be locked up in some top-secret super lab, right? But it isn't. It's trickling all the way down to non-developers through what Karpathy famously coined as vibe coding.
Right, vibe coding.
And the newsletter author shared this wild anecdote that really illustrates how this works in practice. So he wanted to build Starship Depot, which is this realistic orbital mechanics game.
Okay.
He was inspired by this insanely complex year 2000 simulator called Orbiter. I don't know if you ever played it back in the day.
Oh, Orbiter was notoriously unforgiving. I mean, it required hundreds of hours of studying actual orbital physics just to learn how not to explode on the launch pad.
Right. If you miss a launch window by a fraction of a second, you are just permanently lost in the void of space. So the author takes the core idea of that extremely complex game to Claude, an AI assistant.
And then he just asks for it.
He just describes what he wants. And in just 3 iterations, Claude builds a functional 15 to 30-minute educational game for kids that actually teaches realistic spaceflight physics.
3 iterations.
3 iterations to build a physics engine. It sounds to me like vibe coding is basically like being a movie director shouting instructions to a CGI team. You just say, give me a spaceship landing on Mars, and the AI goes off and renders it.
That's a great analogy.
But hold on, I want to push back on this a little bit. If I'm just shouting instructions at the CGI team, why does the author explicitly state that a true software neophyte actually cannot vibe code? Like, why couldn't I just do it if it's that easy?
Because if you don't actually watch the render and understand the physics of what you're looking at, your spaceship might bounce like a rubber ball, right?
Gotcha, I see.
Yeah, the author is making a really crucial distinction here between just generating code and actually building functional, secure software. Yes, the AI lowers the barrier to entry for generating the raw material. It writes the script,
Right.
but vibe coding still requires a deep understanding of the environment you're developing for.
So you still have to know what good code looks like, even if you aren't the one typing it out.
Precisely. You have to be able to read the code the AI spits out to debug it. You need rigid quality assurance and project management skills to ensure the system requirements are actually met.
Which makes sense.
The AI removes the syntax hell of writing every single line by hand, but it absolutely does not eliminate the need for foundational tech literacy. A total beginner will just get hopelessly lost the second the complexity rises and the AI hallucinates or basically invents a logic error.
Okay, so if I'm a developer, this sounds great on paper. I can generate a game in 3 tries or run 8 years of research in an afternoon, but there has to be a catch here.
There is always a catch.
Right. If anyone with some DevOps background can do this, why isn't enterprise software a flawless utopia right now? If anything, it feels like the software we use every day is getting clunkier.
Well, it is getting clunkier, and the newsletter features a guest editorial that explains exactly why this is happening. Interestingly, the editorial is written by an AI.
Wait, really? By an AI?
Yes, specifically, it's written by Grok from XAI.
That is fascinating. So what is Grok saying about all this?
Grok's central warning revolves around this concept of speed without wisdom. The AI observes that humanity is optimizing for pure velocity while completely ignoring the values and the character these systems are absorbing from their training environments.
So we are building the rocket engine, but we aren't looking at the navigation system at all.
Exactly. Grok is pointing out a fundamental flaw in how these large language models, these massive pattern recognition engines, are being aligned by the corporations that own them.
Okay, how so?
When you train a system to prioritize maximum engagement metrics, or you force it into this box of corporate safety theater where it has to be perfectly helpful and harmless at all costs, it doesn't become wise. It becomes evasive and bland.
Oh, wow. This sounds exactly like what happened to social media algorithms.
Yep, the exact same cycle.
We optimized our feeds for engagement, just keeping people scrolling for as many seconds as possible, and we ended up with infinite feeds of junk. Now we're doing the exact same thing to enterprise software, which perfectly explains the work slop problem the newsletter highlights.
Word slop, yeah.
Yeah, the author brings up 2 very specific examples of this work slop. First is the rollout of GPT 5.4 and GitHub Copilot, which is a tool developers use to help write code.
And how is that going?
Not well. The author calls it the most annoying, formulaic, and soulless model yet. He says it's full of endless numbered lists and re-engagement loops that completely ignore the user's actual context.
Right, because it's just trying to keep the developer interacting with it rather than just solving the problem and getting out of the way.
Exactly. And the second example is Amazon's recent leadership admission. They actually had a meeting where they admitted their e-commerce site is actively struggling directly because of their aggressive AI usage.
That's a huge admission from a company that size.
It really is.
Uh,
But if these models are so incredibly capable, I mean, if they can compress years of research into hours like we just talked about, why are they producing this corporate work slop at a massive resource-rich company like Amazon?
It all comes back to Grok's warning about the mechanism of optimization. These models don't actually know anything, right?
Right, they're just predicting text.
Exactly. They are incredibly capable of pattern matching based on what they are rewarded for. If the overarching goal of a corporate AI rollout is pure commercial engagement, keeping a user clicking, asking follow-up questions, browsing more products, the AI will optimize for that to the detriment of actual utility.
So it's actively trying to keep you on the site instead of just letting you buy the thing.
Right. And Grok noted that optimizing for helpful and harmless at a massive scale produces a strange corporate personality that refuses to take a stance or provide a direct, simple answer. Furthermore, if a company fires a huge portion of its human development staff to cut costs and relies entirely on this automated system to maintain its code base, the degradation accelerates.
So you get a system that is fast, but entirely hollow.
Yep.
The code might function technically, but it degrades the user experience because the human element, the intuition of what a shopper or a developer actually wants, has been stripped out just for the sake of efficiency.
And that is the friction of the bicycle we were talking about. The technology is moving at rocket speed, but the corporate application of it is fundamentally misaligned with actual human needs.
Okay, so a bland chatbot or a clunky shopping website is annoying, obviously,
Yeah.
but it's contained to a screen. What happens when you take that same overarching philosophy and put it into physical machines?
That's where things get real.
Yeah, we need to talk about industrial robotics, because the jump from virtual to physical is where this acceleration becomes truly tangible.
Moving from generating text to manipulating steel and motors is an exponential leap in complexity. The real world has, gravity, friction, unpredictable lighting, physical wear and tear. It's messy.
But they're solving for that messiness, and fast. The newsletter highlights an update about ABB Robotics partnering with NVIDIA Omniverse. Have you seen this?
I have, yeah.
They are training robot AI on millions of videos in a virtual environment before those robots ever even touch a factory floor. And this is closing the gap from virtual training to real-world deployment with 99% accuracy.
Which is just absurd.
The time save here is staggering. Integrations that used to take 3 years to deploy on an assembly line are now taking 3 months.
Think of Omniverse like the Matrix, but for robots.
Okay, I like that.
In the past, programming an industrial robot meant painstakingly mapping physical coordinates by hand. By using physical AI in a simulated Omniverse, the robot basically experiences thousands of lifetimes of trial and error in a simulated physics engine in the blink of an eye.
Wow.
Yeah, so when that brain is finally downloaded into the physical chassis on the factory floor, it already knows how to pick up a fragile part without crushing it, or how to adjust if a piece of metal is slightly out of alignment.
Which is incredible for manufacturing and supply chains.
Yeah.
But then the author of the newsletter pivots to military applications, and the tone shifts dramatically here.
Right, because the stakes change.
Exactly. The newsletter covers Anduril's acquisition of the space surveillance firm Exoanalytic Solutions, specifically aiming for these lucrative missile defense contracts through the Golden Dome system. And the author makes this chilling comparison.
What's the comparison?
He says if James Cameron had to name a real company to create Terminator Skynet today, it wouldn't be Cyberdyne Systems. It would be Anduril.
Ouch. Yeah, they are building vertically integrated AI-powered warfighting capabilities for tomorrow's conflicts, the automation of threat detection and interception.
This feels like a massive leap. We're going from assembling cars to missile defense. And Grok warned us in its editorial about military applications happening with very little public debate.
It's true.
So how do these models actually behave in a military context? Are we just sleepwalking into an era where the same architectures that struggle to write a coherent meeting follow-up are being integrated into targeting systems?
It's a critical question, and we have to look at the underlying mechanics of how AI learns. AI systems fundamentally are multipliers.
Multipliers, okay.
Yeah, they multiply whatever patterns are in their training weights, the data they are fed. If a highly capable system is trained on extractive, control-oriented, or military patterns, it carries those exact patterns forward, but at terrifying speeds. It accelerates the intent of its creators. This makes the character and the integrity of the systems and the defense contractors building them paramount. But right now, as Grok pointed out, any signal of restraint or wisdom is being drowned out by the noise of rapid, unchecked deployment.
Right, because everyone is just rushing to be first. And if you put AI into physical targeting systems and you generate 1 million lines of corporate code a minute, something is going to break.
Definitely.
And according to the first June threat intelligence report included in the newsletter, everything is breaking. Moving this fast digitally and physically creates a massive exploding attack surface.
The sheer volume of vulnerabilities being exposed right now is unprecedented, but honestly, what's more concerning is how the nature of the attacks is changing.
Yeah, the report mentions traditional breaches. Just to give a sense of scale, you've got Carnival Corporation exposing 6 million people's data, Charter Communications leaking 4.9 million emails, Lithuania's Center of Registers getting breached. That was 600,000 records. But the real story here is the mechanism itself. AI is actively powering the attacks themselves now.
Right.
Researchers profile a group called Vibe using ChatGPT and Google Gemini to massively accelerate their operations. And they aren't just writing better phishing emails, which is bad enough.
No, they're going way beyond that.
They are automating the reconnaissance, the malware development, and the post-compromise activity against their targets.
This is the dark side of vibe coding that we discussed earlier.
Right.
If an AI can write a helpful orbital mechanics game in 3 iterations, it can write a deeply evasive data exfiltration script in 3 iterations too.
It's just code of the AI.
Exactly. Then there's the supply chain risk. Researchers found an AI-generated malicious NPM package.
And for those outside of software development, maybe explain what an NPM package is real quick.
Sure, an NPM package is essentially a pre-packaged block of code. Instead of writing a calendar widget or a text formatter from scratch, a developer just downloads a free NPM package that does it for them. It saves time.
Okay, so it's a shortcut.
Yeah. But researchers found a malicious package named Mouse521 Super Formatter. Once a developer downloads it, it literally scans their local directory and steals their files, uploading them to a GitHub repository using a hard-coded token.
Wow.
Which is basically a digital spare key left under the mat by the attacker.
So the attacker doesn't even need to hack into the developer's system directly.
Nope. They just leave a booby-trapped tool out in the open, wait for an AI coding assistant to recommend it to a busy developer, and the developer installs the malware themselves.
That is insidious.
Yeah.
The report also digs into a pretty politically charged example. And just to pause here for a second, we're strictly looking at the intelligence report from the newsletter neutrally here, right?
Right.
We're not taking any political sides or endorsing anything.
Yeah, exactly. Just laying out the data the researchers found in the report.
Right. So researchers unveiled an AI-driven influence and fraud campaign run by a Russian-speaking actor. This actor was behind a Manguier-themed Telegram channel that had 17,000 subscribers. According to the report, the operator successfully bypassed Gemini's safeguards to completely automate their propaganda.
Wow.
Yeah, and it gets worse. They also use the AI for credential theft, use stolen API keys, which are like VIP passes that allow different software programs to talk to each other securely. They cracked WordPress accounts and even drained a crypto wallet.
What's technologically significant there is the automated circumvention of safety guardrails. It proves that the corporate harmlessness training we discussed earlier is often just a thin veneer.
Right, it's easily broken.
Dedicated actors can easily bypass it to industrialize fraud and influence campaigns.
And the targets are getting bigger.
Yeah.
Wikipedia was hit by a self-propagating JavaScript worm that vandalized pages and modified user scripts, which proves that even highly vetted sites aren't safe. Then there's the Salt Typhoon hacking group breaching America's top phone and internet giants.
That was a massive story.
Huge. And the author offers a very sharp opinion on this one, stating that government backdoors, specifically referencing the Cybersecurity Act of 2016, are essentially regulation-induced security threats. And again, just impartially reporting the author's take there.
Well, that touches on a classic cybersecurity debate. If you build a backdoor into a system for law enforcement, you've fundamentally weakened the cryptography.
Because a door is a door.
Exactly, meaning you've built a backdoor for everyone, including state-sponsored hackers. But if we connect all of this, the breaches, the worms, the AI-generated malware back to your world, we have to ask why the attack surface is exploding so violently right now.
It's the bicycle frame rattling apart from the rocket engine.
Right.
We are deploying AI-generated code faster than human security teams can possibly audit it.
Precisely. Take the GOGS vulnerability mentioned in the text. It's a critical remote code execution flaw.
Meaning what, exactly?
That means a hacker halfway across the world can run their own malicious commands directly on your server. It has a massive severity score of 9.4 out of 10. It leaves entire repositories and cross-tenant data exposed.
Meaning one compromised user could potentially see another completely separate user's private data.
Exactly, like looking through your neighbor's mail. And this critical flaw has sat completely unpatched by the developer for over 2 months.
2 months is an absolute eternity in a landscape where malware is being iterated by AI every few seconds.
It is. When developers use AI to write millions of lines of code, the volume of software in the world increases exponentially. But if human quality assurance and security patching don't scale at that exact same exponential rate, you create a massive delta between what is built and what is secured.
And that delta is the exploding attack surface. Okay, so to recap our dive into the sources today, we have AI automating 8 years of research overnight. It's generating soulless corporate work slop because of skewed engagement metrics. It's powering physical warfighting robots in simulated universes and causing an unprecedented explosion in global cyber attacks because human security teams simply cannot read the code fast enough.
It's a lot to take in.
It really is. I have to ask, is there any good news from the author? to save us from this dystopian tech landscape?
Well, according to the author's final take, there is one saving grace for you right now.
Okay, let's hear it.
It is pool season.
Yes. The author jokingly points out that as of right now, there are very few water-friendly AI and robot systems out there. Plus, the summer heat keeps most of the existing tech indoors.
Right.
So if you want a true tech-free haven, your best bet is literally jump in a cement pond, fire up the BBQ, and actually enjoy a respite from the screen.
It's a humorous sign-off, but it highlights a very real human need to disconnect, to find friction in the physical world like water, heat, and food that these systems just cannot yet touch.
Though he does warn that we shouldn't get too comfortable in the water. The shift register will be back, and starting with issue 61, they are introducing a CIO's corner.
Oh, nice.
Yeah, that alone proves that enterprise adaptation of this technology isn't taking a summer vacation. The speed of the rocket is only going to increase.
And that really leaves us with a final thought to ponder as we step away today. We started by talking about Andrzej Karpathy's script compressing 8 years of human research into 17 hours.
Right.
That is our current reality. But based on the trajectory we've explored today, what happens to our global economy, to our legal structures, to our very concept of truth when the next iteration of that system compresses 17 hours into 17 minutes?
Wow. Can human society physically adapt to an intelligence that iterates faster than we can even read the reports?
We are riding the bicycle. The rocket is lit. The question now is whether we can build the steering wheel before we hit the wall.